Welcome to Brain Vision.
A constant force of 3.7 times 10 to the 4 newtons is acting on the airplane, and it makes the airplane takes off. At the same time, there is some force acting on the pilot of that airplane as the airplane takes off. What is that force? So to know that, we have to note the following. The pilot is constrained by the seat belt to accelerate together with the airplane. So what we know is that the acceleration of the pilot is the same as the acceleration of the airplane, and I will call it A. Let me call the mass of the pilot M prime, not to confuse with the mass of the airplane. So all we have to do now is calculate the acceleration of that airplane by using Newton's second law. By doing that, we get the following. The force is equal to the mass times the acceleration. Therefore, the acceleration of the airplane is equal to the force divided by the mass. And then it is equal to 3.7 times 10 to the 4th divided by 3.1 times 10 to the 4th. There is a simplification of this 10 to the 4th factor, and you get 3.7 divided by 3.1. Now that we know the acceleration, we can calculate what is the force that is acting on the pilot, because we know now that the acceleration of that pilot is equal to 3.1, because he is tied to the airplane by the seat belt, so they must accelerate together. Now, how can we calculate the force that is acting on the pilot? We can do it again by using Newton's second law. The force that is acting on the pilot is equal to the mass of the pilot, m prime, times its acceleration. And this is equal to 78 times 3.7 divided by 3.1. And this gives us approximately 93 newtons. And this is the force that is acting on the pilot.